We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Dear students, today we will discuss a listening and battening system, topic of steel structure design. So in this video we will discuss the listening battening, how it's used, and the design procedure of listening as per the IS 800 2007. So for large load and efficient use of material, it is desirable to build a rolled section at some distance and interconnected them. The spacing and the orientation of the elements, it means components, be adjusted such that the slenderness ratio about both axes are same. So this arrangement of column made a 2 or more component is called built-up section. So there are generally made up angle, channel or I section and properly connected along their length. These typical joints is called lessening or battening. So the typical joint of components is done by 2 way, namely lacing and battening. So lacing bar or batten plates are not designed as a load carrying member, but they can carry transverse shear force which occurs when the column effect. So before we start lessening, we know the function of lessening and battening plate. So the function of lacing bar or battening plate is to be hold the main component of built-up section in their respective position and the stress to resist in them. So the lacing bar or batten plates are not designed as a load carrying capacity, but they can design to resist transverse shear force without occur the column effect. Now when it should be used for lacing bar, we can see the next figure. You can see lacing bar should be provided at a bridge, steel bridge, or you can say the any tower of high rise, mobile tower or bridge. You can see the figure. These are the types of lacing we should provide it. So these are the functioning of lacing. Next, there are 2 type of lacing system. First one is single lacing system, second one is double lacing system. You can see nearly in the figure, first one is a single lacing system. It means you should provide in a single way of lacing, and second one is double lacing system. So the lacing system should be varies throughout the length of the strut as far as practicable possible. Now the single lace system on opposite side of main component should be preferable in a same direction so that one system in shadow of other. Cross should be provided along the length of column with lacing system unless all force resulting from deformation of column and member are calculated and providing for in lessening and fastening. Now we start the design requirement for lessening as per the IS 800. So it start at a clause number 7.6, page number 48. Now first requirement, angle of inclination is denoted by theta. It's given to you clause number 7.6.4. For single or double lacing, it should be a varies. So theta may be 40 degree to 70 degree, the axis of built up member. Normally we take theta is equal to 40 by degree. Why? Because you have to take theta 45 degree. So throughout the column your lacing plate should be equal number. So you can arrangement done by uniformly at a 45 degree. So generally we take theta is equal to 45 degree, but you may be vary 40 to 70%. Second one is slenderness ratio. We denoted by KL upon R. It gives to you clause number 7.6.5.1. Now KL upon R for each component of column should not be greater than 50, or KL upon R not greater than 0.7 times most favorable slenderness ratio of the member as a whole. So there are the two criteria to selecting KL upon R is given to you clause number 7.6.5.1. Next, slenderness ratio of lacing shall not be exist 145, means 145. It's also given in clause number 7.6.6.3. So these are the three criteria for slenderness ratio. Next one will be the effective length of lacing. So first we start effective length of lacing is denoted by LE. You can see the figure of L. This two lacing center to fastener between the length is denoted by L. Now lacing should be designed in a two way. Either it should be connected by bolted or it should be connected by welding. So in both the case, effective length should be changed. So first we discuss about bolted connection. If you use single lacing, then bolted connection, L effective is L. It means your original length should be same as effectively length. If you use double lacing system, then your L effective is equal to 0.7 times L, where L is equal to distance between inner end of fastener. Now in case of welded connection, effective length of lacing should be 0.7 times distance between inner end of weld. It means our L. You can see the figure how we calculate the L of lacing. Now width of lacing bar. After calculate the effective length, we decide the width of lacing bar. So it's given to you clause number 7.6.2. Minimum width of lacing bar is denoted by B is equal to 3 times D. Now what is D? D is nothing but nominal diameter of bolt hole. So nominal diameter is you have to decide either you should provide 22, 20, 18, 60 depending on the number of bolt you have to design criteria. So next, thickness of lacing is denoted by T. After deciding width and length of lacing, the third component is thickness of lacing is denoted by T. It's given to you clause number 7.6.3. For single lacing, T should be greater than LE upon 40. For double lacing, T should be greater than LE upon 60. What is LE? LE is nothing but effective length of lacing. That we will calculate in our third step. Next, transverse shear VT. Now we can see the lacing should be designed at not loading any component, but it should be designed to carry transverse shears. So this is the very important step to register transverse shears is denoted by VT, and it's given to you clause number 7.6.6.1 in IS 800. Now VT is equal to 2.5% of axial force in column. How we take the VT? It's take 2.5%. Axial force of column is given to you. So this force shall be divided in equally among the lacing system parallel to the plane. Now this force we divided equally for both the lacing plate and it should be parallel to the plane. So for single lacing, F is equal to VT by 2 sin theta. How it's calculate? You can see that figure. This force we take the parallel. So F force, theta is inclination of 2 lacing and converted into the dividing force F divided by 2. It means VT by 2. So finally for single lacing we get F is equal to VT upon 2 sin theta. For double lacing, F is equal to VT upon 4 sin theta, where F is equal to axial force in each lacing bar. So first of all, you have to find out axial force of each lacing bar, and Vt should be taken 2.5% of axial force in column. Now next, check for compression strength. For lacing using Le upon R minimum or Fy is equal to 250 MPa. Find FCD from IS 800 table number 9C. Why 9C? Because we designed built up column. So for built up section, buckling class is C. That's why we use to find out FCD table number 9C on page number 42. So once we calculate L effective, R minimum we decide in according to steel table. According to LE upon R minimum, using the table number 9C, we can find out FCD. Then for rectangular section, buckling class is C, that I already discussed. So the compressive load carrying capacity should be PD, is denoted by compressive strength of load carrying capacity. PD is equal to B multiplied by T into FCD. B is width of lacing, T means thickness of lacing, and FCD is nothing but compressive stress. So if B multiplied by T multiplied by FCD less than F, the axial force and lacing is okay. B by T is nothing but area of lacing. So PD should be greater than F, then your lacing design is okay. So in this step, we have to check that your compressive strength of lacing is okay or not. Next, check for tensile strength. After checking the compressive strength, next we have to check tensile strength. So for the tensile strength of lacing plate, TD is given to you in IS 800 clause number 6.3. There are the two equations to finding out TD. First one is 0.9 times B minus D into T into Fu divided by partial safety factor, or you can say TD is equal to Fy into Ag divided by gamma m0. Ag is nothing but area of gross, and Fu, it means ultimate tensile strength of plate. Now whichever is less, if TD greater than F is okay. So this equation is given to you clause number 6.3.1, page number 32. Now next step, end connection. After deciding the lessening size of plate, we have to check compression and tensile, then we end connection between lacing plate. So the bolted connection for lacing may be two types in given the case A and B. First case, you can provide separate lacing plate without overlapping and bolting. In that case, resultant force of bolt R is equal to F. What should be the resultant force in this case? Total force of lacing. You can see the figure of case A. We can provide different lacing plate with different bolting. We cannot provide overlap between these two. So first case, in that case, R is equal to F. So how can find out number of bolts? So number of bolt required is equal to total force divided by bolt value. Bolt value we can know that the minimum value of shear capacity and bearing capacity of bolt is denoted by bolt value. That will be a discuss in types of bolt. Next, case B. If resultant force of bolt R is equal to 2F cos theta. Now what should be the case B? You can see the figure. We can overlap two lacing plate at the same point through bolting. At that time, your resultant should be 2F cos theta. So R is equal to 2F cos theta in this case. Number of bolt, also the same equation, total force divided by bolt value. But here force is equal to resultant force. It means R is equal to 2F cos theta. So number of bolt required 2F cos theta divided by bolt value. Again, for the shear strength, or you can say the bolt value, there are the two general diameter we can use, 16 mm and 20 mm. So for 16 mm, you know that bolt value is 29, and for 20 mm bolt value should be 45.3 kilonewton in single shear. If you provide in double shear, the value should be double. So there are two cases to provide the lessening at the end. Either you should provide separately and you should provide overlap between them. After designing end connection, you can check the strength of bolt bearing. Clause number 10.3.4. The equation is given to you, 2.5 kb into d into t into fu. D means diameter of bolt, t means thickness of fastener, fu means ultimate stress of steel, and kb is given to you, clause number 10.3.4. So last step, overlap. In case of welded connection, the amount of overlap should be measured along either edge of lacing bar shall not be less than 4 times the thickness of lacing bar. Now where the overlap limits will required, if you provide the welding connection to attach the lacing to the column, in that case overlap must be measure roll to the parameter of connection of lacing. So lacing shall not be less than 4 times the thickness of lacing bar or the thickness of the element of main member, whichever is less. So these two criteria you should satisfy the overlap. So this is the last step to design criteria for the lacing, but this overlap limit should be affected when you have to provide welded. So the design requirement, we have discussed about 10 steps, and lacing should be designed either bolted or welded. Thank you.